Welcome to Lesson 2 on Solving Equations and Inequalities. You guys in general are pretty good at this already, so it's going to be a pretty quick review, especially the equations part. Some of you need a bit more review on the inequalities, so we're going to be focusing our time more on that. And to start out with, we have a kind of fun example. This here is Sully. Sully is a math nerd. He thought the best way to send a message to his girlfriend on Valentine's Day was with a math equation. So in order to figure out the message that Sully sent, we're going to try to simplify this inequality. And this is part of what we're learning today. So we want to simplify this inequality. Looking on the right-hand side, we're going to distribute this 3 that's in front. So I have on one side 9x minus 7i greater than 9x minus 21u. And then we're going to take, we got an x term on both sides. We got an x term here, an x term here. So we're going to subtract 9x from both sides. Sorry, I'm going to get rid of that divide. It looks like a divide sign. It's not. Subtract 9x from both sides. And look at that. It actually leaves us with no x's on either side. So on the left side, we now have minus 7i greater than minus 21u. Let's see if we get the I by itself by dividing out the negative 7. So we'll take that, divide by negative 7, divide it by negative 7. Remember that when you divide by a negative number, you're going to flip your inequality sign. So what was a greater than is now going to be the less than sign. 27 divided by 7, the negatives cancel and we get 3. And we're left with 3u. Well, look at that. I heart you. Kind of sweet. All right, let's get down to business. Now for some more equations. So review, we're going to solve linear equations. Linear means you have no squares, no cubes, nothing like that in your equation, just straight up numbers. So the first thing we're going to do in either case is look on either side and see if there are any like terms we can collect. And like terms, remember, have the same number of each variable. So this has 1n here. Is a like term with this plus 8n here, because they both have a single n. Remember that this n has an invisible 1 in front of it. And 1n plus 8n, well, that gives us 9n minus 2 equals 7. There are no like terms on the other side because there was only one term on the other side. Now, once we've collected the like terms that are all on the same side, we kind of like to collect the like terms that are on opposite sides, and the way that we do that is by doing the opposite operation. So I've got this minus 2 here. If I want to move it to the other side, it's going to be a plus 2. So that they cancel. Minus 2 plus 2 cancel. 7 plus 2. That leaves us on the left-hand side 9n, and on the right-hand side 7 plus 2 is also 9. Now I want to get the n by itself, so I am going to, well, it's 9 times n, so the opposite operation of times n is divide by 9, divide. So divide by 9 on both sides. That will cancel 9 and 9, and it leaves me with, on the left-hand side, an n, and on the right-hand side, a 1. And we're going to start boxing our answers just so they're easy to find, so that when you're checking your homework or I'm checking your quizzes, it's easy to see what your final answer is. So in this case, n equals 1 is my final answer. Now the next one, we could go about in the same way, but we've got a whole bunch of nasty fractions. So I could start out right away going, I'm going to try to add these fractions. It just gets messy. So instead of doing that, we're going to multiply every single term by the least common multiple of all the denominators. So remember last time we talked about what least common multiples are, so we're just looking at the denominators. This 2 has a denominator of 1. This 4, 2, 4, 2. So hopefully you can figure out the least common multiple. The least common multiple of 4 and 2 is 4. So I'm going to multiply every single term by 4. So 4 times negative 2 is going to give me negative 8a. 4 times 9 over 4. Well, this 4 and this 4 cancel, and I'm just left with 9. So minus 9. 4 times 3 over 2. 4 over 2, I can do my cross canceling. So 4 divided by 2 is 2. And that 2 remaining times the 3 is 6. So this is plus 6. Keep the distribution going even on the other side. 4 times negative 1/4. Well, then again, this 4 and this 4 cancel to leave me 1, and then I have 1 times negative 1 is going to be negative 1 on the other side. And the last one, 4 times 3 over 2. This 4 and this 2, 4 divided by 2 is 2. Times negative 3 is going to leave me with a negative 6. So this is a negative 6a. So if you need to do this on your calculator, you could. If you wanted to pop out your calculator and go, okay, what is 4 times negative 9 over 4? Or as fractions, 4 times 9 over 4. If you're using the fraction button on your calculator, whoops, negative 9 over 4. You can get this negative 9. Or if you want to do the 4 times 3 over 2, it'll give you the 6 that we got here. So if you need your calculator, you can use it. But if you can do some simple math in your head to do your cross canceling, you will always end up with no fractions at the end, which is kind of nice. Then from here, this is just the same as our previous question. We want to collect our like terms and then see if we can get the variable by itself. So on my left hand side, I do have like terms of the negative 9 and 6, so I'm going to make this minus 8a. Minus 9 plus 6 is minus 3 equals minus 1 minus 6a. Now when I'm deciding which of these two variable terms to move to get the variable together, I like to choose the smallest term. So between negative 8a and negative 6a, the negative 8a is smaller, it's more negative, so that's the one that I'm going to move to the other side. So I'm going to do the opposite, so minus 8a, the opposite is plus 8a, plus 8a. So that leaves me with the left-hand side just being minus 3 equals minus 1. Minus 6a plus 8a is plus 2a. Now you could have moved the minus 6 if you wanted to. The only thing that it helps out with is it guarantees you a positive coefficient on your variable. But that's not really a big deal if you don't mind dividing by negative numbers. It's really up to you. You could have moved the 6a instead. Alright, then we're going to move these, between these two we want to get our a term by itself, so I'm going to plus this 1 to move it to the other side, plus 1, so minus 1 plus 1 disappears, and negative 3 plus 1 is negative 2, equals 2a. And my last step, to get this 2 times a to the other side, I'm going to divide it, and that leaves me with a equals negative 1. Again, I'm going to box my answer because I kind of ran out of space. It was confusing to see where I went from there. That's a good spot to go back to. Alrighty. This time, number 3, we're going to start with our parentheses to distribute, to get rid of them just like we did with our inequality up here. And to give myself a little bit of room, I'm going to erase what's up here so I have room, just a little bit more room to work with. So I'm going to start out by distributing to get rid of parentheses. So 4 times 1 and 4 times minus 4. And this is going to be minus 4 times 3n and minus 4 times 2. So this gives me 4. 4 times minus 4n is minus 16n. Minus 4 times 3 is minus 12n. Minus 4 times 2 is minus 8. Minus 4, and from here it's all the same steps. So I would collect my like terms on the right hand side, so leave the left hand side alone for a minute. So I have minus 8 minus 4 is minus 12. Then I'm going to move again the smallest of my variable terms, so that's the 16n, so plus 16n leaves me with 4 equals 4n minus 12. Move the 12 to the other side by adding it, so plus 12 leaves me with 16 equals 4n. And divide out the 4 to finish it off. So divide by 4, and it's going to leave me with a final answer. You could write it as 4 equals n. I just like to have my variable on the left-hand side, so I'm going to write it as n equals 4. Box your answer. So remember, this is just a quick review. If you need more detailed, more examples, a little bit slower instruction, I do have a place I can send you to watch a video. So if that's you and you would like to take me up on that, then I can send you to a video to give you some more practice. All right, we're going to move on to numbers 4 and 5. And before I do those, pause your videos, take time to do them for yourself, and then come back and I will walk you through the solution. Alright, and here we go. So again, we start with distributing. 2 to the 1, 2 to the negative 3. 5 is outside the parentheses, so it does not get distributed. Negative 4 to the 2, negative 4 to the 1 gives me 2 minus 6n plus 5 minus 8n minus 4. Collect my like terms, which is the 2 and the 5, to get the 7. Add, again, the smallest variable term, which is 8n, to both sides. Subtract the 7 from both sides, and divide out the 2 to get me n equals negative 11 over 2. All right, number 5. Again, we're going to use the same trick as we did in number 2, finding the LCD of the denominators. So in the denominators, we've got 3, 2, 2, 3, 2. And again, hopefully you can figure out the LCM would be 6 between 3 and 2. This just helps us clear out our fractions. So again, I'm going to multiply every single thing by 6. 6 times negative 2/3, 6 times 9 over 2, 6 times 3 over 2, 6 times 4 over 3, 6 times 3 over 2, and that's going to very conveniently get rid of all my fractions. So again, if you need the calculator to do this, you can. If you can do it, mental math would be even better. So 6 times negative 2/3, 6 over 3 is 2. 2 times this negative 2 is negative 4k. 6 times 9 over 2, well, 6 over 2 is 3. 3 times 9 is 27, so minus 27. 6 times 3 over 2, well, 6 over 2 is 3 times negative 3 is negative 9. 6 times 4/3, 6 over 3 is 2 times 4 is negative 8. 6 times negative 3 over 2, well, 6 over 2 again is 3 times 3, so negative 9k. And once we've done that, we have a simple equation. Again, collect your like terms, move things around. So on the left side, no like terms, leave it the same. On the right side, minus 9, minus 8 is minus 17. The smallest variable term here is this negative 9k, so I'm going to add 9k to both sides. It gives me 5k minus 27 equals negative 17. Move the 27 to the other side by adding, so plus 27, 5k equals 10. And divide by 5. So I get k equals 2. Box your answer. Again, if you need to see that again, you can always rewind the video, watch it on slow speed, pause it between steps, make sure you understand what's going on. All right, that's equations for you. Now we're going to take a look at some inequalities. So there are 4 symbols we use to represent inequalities, and they are less than, greater than, less than or equal to, and greater than or equal to. So even though we give them these names, when we're reading, we're going to read an inequality like this always from the variable side. So x is the variable, so we're going to read it from x, from left to right in this case, which is the normal way we read things. So this is read x is less than or equal to 21. So remember that your crocodile, your alligator, whatever, always eats the bigger term. So x is the smaller term, 21 is the bigger term. So it's easy when the variable's on the left-hand side. You have to flip it around when the variable's on the right-hand side. So in this case, again, we're going to start with the d. The d is getting eaten, so it must be the greater one. So this is d is greater than 3. So again, we always start with the d side, even though this is the less than sign because we're reading it backwards. We read it as d is greater than 3. Think about how you would read letter C. Again, start with the y and move this time right to left. The alligator's eating the bigger thing, so 1 is bigger, so y must be lesser, so y is less than 1. And letter D again, think it through yourself first. Read it from right to left because the variable's on the right side. V is less than equal to 1. Not 1. Less than equal to 3.14. All right. So hopefully you're getting the hang of it. And the reason that we want to read it that way is because that makes it so much easier to graph on a number line if we're thinking read it from left to right. So which would be easier for you to think of? How would you graph d is greater than 3 or 3 is less than d? It's way easier to think, okay, I'm going to start at 3 and greater than is everything to the right, so my arrow goes to the right. So for example, this one is x is greater than, because it's getting eaten, negative 3. So I start at negative 3 and I draw a circle there, and then I think about, oh, do I need to fill in this circle? Remember that anything, I guess I'm going to put this Anything which doesn't include that actual point, so -3 is not less than 3, so less than or greater than is going to be an open circle. Less than equals or greater than equals is going to be a filled in circle because we want to include that point. If you like, anything that's underlined gets filled in. It's like that extra ink goes to fill in the hole because it's underneath, and it includes that point as well. And we want x is greater than -3, so I'm going to start at -3 and greater, everything to the left is the greater than side, so I'm going that direction. X is greater than -3. Something like this, where it's like 1 is less than or equal to x, that's kind of annoying, but I'm going to read it the other way around. X is greater than or equal to 1. So again, I'm going to start at 1, put my circle there. I remember that equals underneath, this equals underneath means fill in this circle because 1 is greater than or equal to 1 because it's equal to 1. And then greater than, x is greater than 1 means, again, I'm going to the left. So I'm going to start at 1, go to the left side. So those are simple inequalities, how I graph simple inequalities. Now I'm going to look at graphing compound inequalities. There are two kinds. One has two less than or equal to signs, and the other kind has an or in the middle. So the first one, again, you can think of this as like two separate inequalities. One says x is greater than -4. So x is greater than or equal to -4. And the second inequality would be this part here, which says x is less than 2. So I want all the numbers that are greater than -4, greater than or equal to -4, but less than 2. So I'm going to put a dot at -4, fill it in because it's at the equals, make that a little neater. And I'm going to put a dot at 2, leave it open because it's not have the equals underneath. And all the numbers that are greater than -4 would be to the left of -4, and all the numbers that are less than 2 would be to the right. So it's all the numbers in the middle between those two. And just make sure that you have the correct open circle, closed circle things. All right, so that's how we do this kind of an inequality. It's the area in between them. When we have an or inequality, we do them each separately. So again, we have two inequalities that we're dealing with, but we can take them each one at a time. So x is less than -1. So less than -1, I'm going to go to -1, open circle, because there's no equals, and less than is to the left. Yep, to the left. Or greater than or equal to 1, so I'm going to put a dot at 1. And greater than is to the right. So I'm going to the right. So both of these, any number that's either in this section or this section, is part of my solution. So or usually has two sections of solution, and or the compound inequality that doesn't have anything is the part in between. So once we remembered how to graph these, we're actually going to use them solving equations. So we're going to solve some simple inequalities this time without graphing, and then we're going to graph some down below. So the first one, again, solving inequalities is pretty much like solving equations, except you have to keep track of this sign in the middle. So we're going to follow the same kind of ideas. So we got this 7 that we want to move to the other side. So to do that, we're going to add 7 to both sides. And now I've got 2/3 x greater than 30. And if you wanted to, you could divide this fraction to move it to the other side. That would be totally fine. But I'm going to do instead multiply by the reciprocal. And the reciprocal means flip the fraction over. So I'm going to multiply by 3/2 on both sides. Flip the fraction, multiply it. This is multiplied to both sides. Because the 3's cancel, the 2's cross cancel, and I'm just left with x, which is what I wanted. All right, and so that gives me x greater than, again, can do 30 divided by 2 is 15. 15 times 3 is 45. If you need your calculator for that, you can, but do as much in your head as possible. So x is greater than 45. Okay, there's one example. Why don't you pause your video now and try example number 6 by yourself, and then come back and watch. All right, here we go. We're going to move the 6 to the other side by subtraction. So subtract 6 from both sides. We got negative 4x less than equal to 4. Divide by negative 4. And remember that when you divide by a negative number, this is where equations and inequalities are a little bit different. You flip the inequality sign. So we still have x on the left-hand side, but this now becomes a greater than equal to instead of a less than equal to, and on the other side we have a negative 1. And that would be it. You'd be done. All right, now we're going to look at solving some compound inequalities. Looking at number 7, we could solve them each separately. So, for example, I could solve just the left-hand side, negative 30 less than equal to 6x minus 3. Or I could solve just the right-hand side, 6k minus 3 less than 57. But I can actually do it all at the same time, solving combined, and so that's actually what I'm going to do. It's up to you if you like to solve it in pieces and then graph the solution. That way it also works. So I'm going to just copy it down underneath so that I can work with it easier. So negative 33 less than equal to 6k minus 3 less than 57. And the same steps as we used up above apply, except we have to do it to kind of think of it as all 3 sides instead of having only 2 sides to your equal sign. We have a left side, a right side, and a middle. So again, we want to get the variable by itself. So we're going to add, we're going to move this 3 by addition. So to all 3 sides, we're going to go plus 3, plus 3, plus 3. And negative 33 plus 3 is negative 30, less than equal to, the only thing left in the middle is the 6k, less than 57 plus 3 is 60. And again, to get the k by itself, we're going to divide off the 6 because it's being multiplied. And we're going to do it to all 3 sides. So divide by 6, divide by 6, divide by 6. So this gets me negative 5 less than equal to k less than 10. So again, when I go up to graph it, negative 5 less than equals, I'm going to fill in, if I can figure out, here's I've got negative 5 here. 10, no equals underneath, open circle, oh dear, 10 is way up here. I'm just going to pretend my number line goes that far. And I'm going to fill it in the middle. This would be my graphed solution, more or less. This is at 10. All right, why don't you pause your video and try number 8, and then we'll come back and finish it together. All right, here we go. I'm going to copy it down underneath so that it's easy to work with. I'm going to move my 5 by subtraction to all 3 parts. So I have negative 13 minus 5 is negative 18, less than equal to negative 2v is the only thing left in the middle, and 7 minus 5 is 2. Now I'm going to divide everything by negative 2. Divide everything by negative 2. What do you need to do when you divide by a negative? That's right, flip your inequality. So 18 divided by 2 is 9, greater than equals v greater than equals negative 1. Now we don't really like having it with these greater than equals signs because it's kind of backwards to how we see it on the number line. So usually we flip everything around, kind of mirror image it so that we get negative 1 less than equals v less than equals 9, which is how we would read it from the variable anyway. So make sure that the things that are still pointing at the v, so v is greater than or equal to negative 1, v is still greater than or equal to negative 1, and this just makes it easier to graph on the number line. So negative 1 is here, fill it in. 9 is going to be way up here, also filled in, and we connect the 2 across the middle. All right, if you haven't done so already, why don't you try number 9 and number 10 on your own, then come back and watch the solutions. All right, here we go. So this time we actually have an inequality that's separated by or. So we're going to do each of these separately. So again, copy them down beneath so you can see it. 1 minus x less than negative 6. Subtract the 1, negative x less than negative 7. Divide by negative 1, divide by negative 1, and this flips it to be x is greater than 7. And my other one, minus 4 less than equals negative 9, add 4, x less than negative 5. So I find 7 on my number line. That's going to be here. It's an open circle. And greater than is going to the right. So this is my first part from x is greater than 7. And x is less than negative 5. So I find negative 5. Oops, I lost the equals. Less than equals. Less than equals. Fill that in. There's my negative 5. And this time I'm headed to the left. All right, if you haven't done so already, go ahead and do number 10, but here we go. Start out with distributing the negative. So I've got negative 1 plus 8n greater than equal to negative 5 times 4 and negative 5 times 2n. So minus 20n, minus 10n. Minus 20 minus 10n plus 1. This is not a compound inequality, kind of nice. Collect my like terms on the right-hand side, so that gives me negative 20 plus 1 is negative 19. Move the smallest variable term, that's this negative 10n, so plus 10n to both sides. So minus 1 plus 18n greater than equal to negative 19. Move the 1 by addition, so plus 1, 18n greater than equal to negative 18. Divide the 18. Do I flip the sign? No, because although I'm dividing a negative, I'm not dividing by a negative. So this is just n greater than equal to negative 1. Take that, fill in the circle at negative 1. Greater than is going to the right. And there you have it. So go ahead and write down a summary of this lesson. If you have any questions, we will talk about those in your next Zoom class. We're quickly going to go over these algebra skills. Again, they're exactly the same algebra skills as we did in the last lesson, so before you watch this, see if you can figure them out on your own. If you need to look back at your notes, that's fine. We're going to look at some graphing, some simplifying radicals, and some solving. So pause your video, try these on your own, and then come back. Alright, so this first one, f of negative 1, this means what is my y value? What is my output when my input, my x value is negative 1? So I come to my graph, I find a value of negative 1 for x. I read down, that's this point right here. And my y value, reading back, it tells me is negative 2. So again, this question is asking, what is my y value when my x value is negative 1? Or what is my output when my input is negative 1? Y-intercept, where does it cross the y-axis? Well, that would be right here at 0, 0. So y-intercept is 0. Letter C, f of x equals 4 when x equals what? In other words, this is my y value. What is x when my y value is 4? So that's up here on my graph is 4. So I read over to my graph, that would be this point right here coming down on the graph. It's a little bit cut off, but I think this is negative 2.5. X-intercepts, where do I cross the x-axis? Well, the first one is right here at negative 2. Then if I keep going over, there's another one here at 0. And if I keep going over, the last one happens here at 1. Those are my x-intercepts. They're also called roots or zeros of a function. Just getting the vocabulary in there. All right, simplifying radicals. We're looking for perfect square factors of 98. So maybe you had to plug some numbers into your calculator for a while until you figured out what they are. But this 98 is actually equal to 49 times 2. And 49 is the perfect square of 7 squared. So this would be 7 times the square root of 2. Looking for perfect square factors of 12. So this would be 2 times root, well, 12 is divisible by 4, so 4 times 3. Square root of 4 is 2, so this front 2 gets multiplied by another 2, and the root 3 stays, for a final answer of 4 root 3. Last one's solving equations. We want to get the x by itself. Well, we've actually been doing that a lot in this lesson. So maybe you thought of using the least common multiple and multiplying everything by 2. That seems like a good start to me. So 2 times 10, 2 times x over 2, and 2 times negative 5 over 2 is going to give me negative 5 plus x equals 20. I just like it better when there are no fractions. Move the 5 to the other side, then x equals 25. And last one, practicing our factoring. Again, we want to find factors of 20, so things that multiply to 20, and add to the middle term, -9. So add to -9. So to add to a negative number and multiply to a positive number, we're going to need two negative factors. So I'm going to just start listing the factors of 20. Could be like -1 and -20. No, that's not going to add to -9. -2 and -10. Nope. We can't multiply by 3. How about -4 and -5? That makes sense to me. So then I'm going to just write my factors as x minus 4 and x minus 5. And if you want to check this by foiling, you can double check that it actually does give you this when you multiply it all out. So that's the end of this lesson. Have fun with the practice, and I will see you at the quiz.